Hi guys. So in this session we are dealing with the most important topic, that is basically when you are going with both CMA inter and CMA final, you are having a common topic called network analysis. So we are dealing with the network analysis. Shall we? So here in the case of network analysis, what is the basic theme? What is the purpose of network analysis? So basically when you are having a thought to complete your CMA, okay, or if you want to construct a house, there is a number of things to be done, and if you are writing these things in the form of a narrative form, common man may understand or may not understand. But however, if you are going with a diagrammatic or pictorial representation, then even a layman can get a basic clarity. So network analysis is nothing but entire project, whatever with the project, whether a CMA completion or a house, a villa completion and all, is being depicted or presented in the form of a picture, okay, by using arrows and all. So this is nothing but arrow diagram. It is also known as what ma arrow diagram. Okay, sir, in the case of your CMA, there are basically three stages: foundation, inter and final. And between inter and final there are articles. This is the process. If I write this in the form of narrative way or descriptive way and all, you may not be getting clarity. But if I show in the form of pictures, stages in the form of flow chart and all, you will get more clarity. So in the same way, network analysis is representing every complex situation into simple diagrammatic representation. Okay, so there are some fundamentals. The basic fundamental is that activity. Sir, what is activity in the case of network diagram? The basic first fundamental ma. So listen carefully. So while you are solving this part, fundamentals are most important. Okay. The operations are represented by using an arrow. Sir, in the case of CMA, there are three stages now: foundation, inter, articles, and final. The four stages, articles are excluded basically. These four stages, if they are represented in the form of arrows and we are constructing a flowchart or a diagram, okay, that is this one. But however, each activity or each task in the project will be represented with the help of an arrow, okay, and it is represented with the letter of capital letter. There is different representations. Either you can use a capital letter or you can use numbering also, okay, 1 2 or capital letters for sure. And while you are representing or while you are forming a network diagram, the basic thing is that construct the diagram with a pencil first. If it is satisfied, then you can frame with a pen and all, no issues. And straight away, if you are doing with the pen and all, there can be different adjustments. If the adjustments are not done properly, the result maybe not be effective and it won't be superb. Thing is that diagram should be neat and tidy enough. So present it in the form of pencil first in the rough. If you are satisfied that question in the question, what are conditions given are satisfied, then you can go ahead with the pen. Okay. So first, their activity should be presented in the form of alphabetically and ascending order. That is A, B, C, D, and all. Okay. So the best example is this. We are representing in the form of capital letters, basically. Okay. Can also be represented with the numbers. That is 1, 2. So this is activity. Activity A can also be represented as 1, 2, or B can be represented as 2, 3. So from here, for example, B starts basically. Okay. Now, but never with the numbers. The activities will never be represented with the numericals and all. Only letters. The two capital letters are used basically. Okay. Now, there is one more term. What is meant by predecessor? Basically, sir, normally for activity B, it is represented with an arrow that has starting event, ending event. So this is B. For B, what is preceding it? A. Okay, that is predecessor. And for C, what is preceding it? B. Sir, predecessor and successor are very important. Why? Because in the question they will be giving activities and what are preceding them or what are the predecessors. Okay. So for a C activity, what is the predecessor? B is a predecessor. And for B activity, what is the predecessor? A. This is the basic part and basic terminology. Sir, activity is clear now. Sir, how the activity is represented in the form of arrow and it is represented with the letters. Either numericals also can be used. That is 1, 2, but never with a single number basically. Okay. And what is successor? Sir, for by having the knowledge of predecessor, you can get clarity of successor also. What is that, sir? It is very easy, ma. For activity A, what is coming after it? That is successor. And for activity B, what is coming after it? See, those things will be successors. Okay. And what about concurrent? Sir, if two activities are starting simultaneously from one point, So if two activities are starting from one point at the same time, they are known as concurrent activities. Clear? Next. So there is one more basic important thing regarding directions. The directions can be forward, upward, or downward, but never in the case of backward or curve. Basically, they will never use curves. Exception, there are some sort of exceptions. Normally, for your level, there are no curves and all. Okay, but there can be loop like this. Okay, that we shall see. So, what are directions, ma? Forward, upward, and downward, and never in the backward or a curved direction. Okay, and one more thing. There always the arrow starts from left and ends to right. Direction is always from left to right, never from right to left. This is not at all followed. Always left to right. Okay, so is it clear now? And never right to left, and even top to bottom also not at all used. Basically, these are the basic fundamentals. You have to follow these things while you're drafting a diagram. Okay, and here if we go further, this is one example now, and let us go with other parts also. So regarding direction also, the basic fundamental rule is that always from left to right. So this way, this will be the appropriate diagram, and never in this way or never in this way. I'm showing what should not be done also. Mainly from exam point of view, these rules should be definitely followed. Okay. And next, sir, what is that, sir? Next most important thing is the event. Sir, what is meant by event? Event represents what ending and starting of an activity. Okay, so if this is an activity, the starting part is an event and ending part is also event. It is also known as node. Okay, whatever this circle it is there now, this part is known as what starting event for the activity, and the ending part is ending event. The starting event is known as tail part. What is that starting part is known as what tail part, and ending event is known as head part. Is it clear? Because we give some sort of representations for the starting part, starting event, and ending event. So they are very, very important. So now, the starting point and ending point of the network must be a single event point. Okay. So for this, there is single event, and for this, also there is single event. Basically, it's the basic fundamentals. And next, that by seeing this, can you try to draft a diagram with the basic fundamentals which you have drafted? The first column is giving information regarding what activity, and the second part is representing information regarding preceding. Okay, so for activity A, what is before it? So terminology is important. Preceding and succeeding. Preceding means before it. Succeeding means after it. Okay, so let us start a diagram. Sir, here basically the purpose is clear now. So this can be any, for example, if you are constructing a metro, there can be a number of activities, a number of tasks. These should be represented in the form of arrows, so that for a guy like engineer or anyone, he can get the layout of it, how it starts, how it ends, what can be done parallelly, what can be done simultaneously, and these things can be done. What cannot be done without starting someone. Okay, so after completion of one event, only one activity, we can start other activity. This information can be given or depicted by the layout or print or network diagram, whatever we are doing. Okay, sorry. So in this case, we are having how many activities? Two activities in the activity column, and he also gave preceding column. So totally 4 activities are present there. So basically, so activity C, what is the preceding A, and activity D, what is preceding B. So let us do that first. Basically, basic way of diagrams and all. Okay, so if you take this as activity A, it is represented in the form of arrow, and it should start from a left to right. Okay, next after that, what is there C? Clear? Next, what about next one, sir? There is activity D, and preceding that there is an activity called B. Basically, so activity B is preceding, so this is D. Sir, but this is a basic way of representing, but there are some sort of rules. What are those rules, sir? The basic rules is that there should be one starting event and one ending event for entire project. But here, if you see the diagram, there are 2 starting events and there are 2 ending events. Okay, so it is not at all appropriate. Clear? If we go further, let us how to construct it perfectly so that it will be effective. Okay, some parts of this question, basic question. Sir, activity A. Sir, anything is given, any information is given that preceding B or preceding A, is there anything? No. And regarding B, is there anything preceding? So nothing there. So both A and B are starting simultaneously. They are concurrent. Am I clear? They are concurrent. And after A, what is starting, ma? It starts with a C. And after B, what is starting, ma? D. So once the diagram is done, please have a cross check with the question. Okay, whatever things given in the question, are they satisfied or not? If they are satisfied, the way you are doing is perfect. But one more fundamental rule is that, what is the fundamental rule I said, ma? There should not be more than one starting event and more than one ending event. Sir, here superb. Only one starting event. But what about the 2 points, ma? More than two ending events. So to have a better diagram, what I will do, ma? This is not at all appropriate. So I'm reframing it. A and it is B and it is C and it is D. This is a perfect diagram. Sir, now see all the basic rules. Sir, activity is represented in the form of arrow and it is represented with the letters. And so activity A and activity B, there are no preceding parts. Check the question just. If you're checking the question and all, if it is satisfied, then it's super. Okay, and next one more thing, ma. And starting one event, ending one event. Always direction left to right. From left to right. Okay, these are basic fundamentals regarding the question. Clear? If it is clear, what is next one? Sir, do not use, sir, they are asking you to represent the activities in the form of arrows. But you should not use extra arrows. Whatever required, that should be used. Because arrow represents what, ma? An activity. Activity consumes what, ma? Either resource or a time. For example, if the construction of wall is an activity, it consumes time. For example, 5 days. And it also consumes resources. Okay, both are consumed. So activity, whatever you are representing, it should be perfect one or only required. Do not use unnecessary. Okay. So never draw any extra arrows which aren't necessary or which do not show any activity. Basic rule. Okay. Now, sir, there is some other point called danglings and loop. What is this, sir? By seeing this diagram, see the points. First, so what is the basic fundamental rule? The basic fundamental rule is that starting should be one event and ending should be one event. But however, by seeing this arrangement, there are more than two ending events. So such a dangling should not be present. So to make it perfect, we need to either go and extend till there. Okay. Is it clear, Mom? If it is clear, and one more thing, this is dangling. What about loop, sir? Sir, loop in the sense, for example, if we see F, okay, F, after that they are going to G, that I, next what, Mom? So basically, if I rearrange them for your convenience, if I change the directions, you see once. Sir, is this a loop or not? Sir, once you travel this line, when you are entering into this line and all, it is okay, from G to I, from I to J, from J to H, again and again, it is going like a loop. Sir, never create loops and danglings in the network diagram. If you are creating, it's gone. Okay, because the fundamental thing is that it is never-ending process. A loop is a never-ending process. When the loop is a never-ending process, is it useful? It is not at all, because the project is showing starting and ending. Okay, so such things should not be encouraged, basically. Okay, and never those things will be repeated there in the case of exam. Is it clear, Mo? If it is clear, superb. Next, shall we go with other parts? Now, sir, to rearrange them, I'm going with a proper presentation. The way of representation should be effective, and if you are not representing properly, it's gone. See, now is there a loop? No. And in the case of this diagram also, to make it correct or to make it appropriate, we should extend the D portion till the I. Normally we can arrange it properly, but I'm giving the information. So never there should be langlings or loop. Is it clear? Next. Then the next basic example. From this, can you try to construct a network diagram? So in the case of network diagram, if you're perfect with the construction of diagram, everything is easy. Because the first basic fundamental step is that construction of diagram. Okay. So now let us do it. Shall we, ma? And while you are doing, Pause the video here, you try once and then compare your answer with my answer. What is the reason, sir? Because whenever you are trying to find the answers from your own way of doing, then it's fine. You are making some work to your brain. Or else, so let us anyway solve it, we shall see it, and then we shall do it. Then it's of no use. Because in the exam point of view, if there is chance for some new idea or new question, then you may be getting fear. So to avoid that, practice the itself. So pause the video here and try to do it. Okay. So let us do more. So in the case of question, so he gave three activities in the activity column, and in the preceding column he gave two activities. So now by using this, we shall start. Sir, preceding activity preceding A, is there anything more? No, there is nothing. So straight away we can start that one. That is activity A. Sir, what is next, sir? Even preceding B also there is nothing. So preceding A and preceding B, there is nothing now. As there is nothing preceding them, automatically what does it represent? They are starting simultaneously or concurrent activities. Okay, so now we are going to B. And one more kind request, while you are going with the OM, the two in the case of this topic is applicable for CMA inter also and CMA final also. So when you are solving the network diagrams and all, basically try to do it with a pencil first. If it is satisfied, go with a pen. Am I clear, ma? So basically, if you are doing with a pencil, then you can arrange the arrows, what the length is more or not. So the diagram will be effective, basically. Length and all not important, but if you are representing them properly, then it will be good. Okay, now A and B are done. Sir, what about next, sir? Sir, he is giving information that C starts after the completion of A and B. Okay, so now how it is a professor? Think once and tell ma. Is it possible? So let us go with it. C starts after the completion. C, fine. Is it done? Is it done, ma? Sir, a diagram is done, but what are the basic fundamentals that are being violated? Sir, there is starting one event, but two ending events. As it is a violation, sir, I will rearrange it properly. A, B, second, A, sir, C. Now, is it satisfying the condition? Sir, one thing is sure, starting one event, ending one event, but cross check, have a cross check with the question. Sorry, have a cross check with the question. What do you have to do, sir? Sir, while you are having a cross check with the question, sir, preceding A, preceding B, nothing there is there. So A preceding there is nothing and B preceding fine. But what about C? C starts when A and B are completing. So even then, so sir, fine, sir. C is starting after the completion of B. But however, is it starting after the completion of A? No. So when the rules, when you are done with the diagram, have a cross check, reverse check, whether all the conditions given are satisfied or not. And there should not be never satisfaction of any other additional conditions. Is it clear? If it is clear, sir, here there is a requirement of something called dummy. In this scenario, what are we using? We are using something called dummy. Okay. So I'll give the points, dummy activities. Let us complete that one first so that you can get a clarity. Sir, dummy is used only to maintain the logical flow of a diagram. And dummy do not consume resources or time. Okay. So to complete this diagram which satisfies all the conditions, I'm representing like this. It is A, okay, and B is also starting simultaneously. There is nothing preceding. And now if I go with C here, but to go with the logical flow, I'm representing a dummy with a dotted line. This is nothing but what my dummy activity. The dummy activity do not consume any resources. So once the diagram is done, whether the use is appropriate or not, how to check that, ma? Just go to the question. Have a cross check. Sir, what is the basic fundamental first step, ma? Preceding A, there should not be. Preceding A, is there any activity, ma? No. And what about B, ma? Preceding B, there should not be any activity. Even they're satisfied. What about C, ma? C starts after the completion of A and B. Whether it is done or not. C, ma. Sir, B is done. From there, C started. What about A, ma? Sir, A is done till here, but we are extending it logically by using a dummy. So both the conditions are satisfied. Okay, this is one point where we can use dummy. Sir, as they gave permission to use dummies, it is not appropriate to use dummies as much as you need. To use them most appropriate things only, whatever required. Okay, so for dummy there are some sort of rules. Dummy activity, what is one? It denotes no activity and it does not consume time and cost. Okay, cost in the sense of resources basically. Okay, this activity is used only to maintain what my logical flow of a network diagram. It is represented with dotted lines and without indicating any alphabet. So this is a way of representation. Okay, so and you can give it as a dummy also if you want. If you are giving a letter for that, represent the letter with a note point as a dummy, or better to write dummy as. So if you are having more than one dummy, you will give dummy 1, dummy 2, dummy 3, so on. Okay. The next, there are only two cases where we are using dummies. The first case, what is the first case for? When two activities are having same starting and same ending event. What is that point, ma? When two activities are having same starting and same ending event, then we use dummy. Okay, so let us go with an example. This is a previous example which I discussed. Okay, and even we constructed diagram. So what is the basic rule, ma? Two activities are having same starting event and same ending event. Okay, let us see the point first. The earlier diagram which we have done regarding this. Okay, basically normally if we see this part, so A is an activity and they also said that at the same point B also starts. Okay, sir, started B. And whatever he is telling me, C starts where both A and B end. So normally by that point we can draft like this, A and B. So now in this case, is it clear, ma? Sir, A and B activities are having same starting event and same ending event. So this won't be appropriate at all. So two activities cannot have the same starting event and same ending event. So to maintain the logical flow, what are we doing, ma? We are using dummy. Is it clear? So this is the first case where we can use dummy. If two activities are having same starting and same ending, okay, then automatically we are using dummy. Is it clear, ma? If it is clear, this is the first case of using dummy. So is it clear, ma? It is the first scenario where we use dummy. If it is fine, shall we go with other part? So let us go with the first part basically. Whatever theory there mentioned. Sir, when two activities are having what, ma? Same start event and end event. So this case is clear now. So if this case is clear, you are very effective. This is the first case where we are using dummies. Sir, for dummies also there are rules. Should not violate those rules basically. Okay. So if it is fine, what is the next scenario, ma? In the next case, we are going the next scenario. What is the next scenario, sir? Sir, next scenario is regarding the usage of dummies, but there will be a straightaway hint for us. For example, an activity repeats twice in the preceding column. What is that point, ma'am? An activity repeats twice in the preceding column, one individually and others can be combination. It is not just twice, ma'am. It can be more than twice also. Okay. So, for example, in the preceding column, what is the activity repeating there? B, it is repeating individually once, and other times it can be with any combinations. Okay. So B is repeating twice here basically. So minimum 2 times. One is individually and other with a combination. Then from that B point, we have to start dummy. So see the content now. If any activity occurs at least 2 times in the preceding column, that is one time separately and other time simultaneously with other activity. Other time it is a combination. So now in this case, how to construct the diagram, sir? That is important. Shall we? Sir, basically in this case, what he gave ma, activity A is common. There is nothing preceding. Okay, and even in the case of B also there is nothing preceding. What about C, ma? C starts after the completion of A and B basically. Okay, sir, now what is the point of doubt there? Sir, as you said C starts, I will start here C, and one second, ma, I will extend this for your convenience. This is C, sir. I will start the dummy from B. This is one way. Okay, as I said the rule now, if an activity is repeated twice or more than twice in the preceding column, then from that activity you have to start dummy. This is a basic point basically. But however, sometimes you may also draft a diagram like this. Okay, and this is C and divided by this. If you are doing like this, what is violating there? See the point. Sir, again, what is he telling, ma? He is telling that in the next part, see the next part there, ma? D starts after the completion of B. What is the point he mentioned, ma? D starts after the completion of B. So, superb, sir. Anyway, you said I will start there. So, B, that is D. Now, how many ending points are there, ma? 2 ending points. So, while using dummy also, if you are following the logic or pattern, then you will be safe. Is it clear? So, this is not appropriate. Okay. So how to make it appropriate? So I said the logic now. What is the logic we said, ma? The logic is that whatever activity is repeating twice, from that we have to start dummy. So I started there. Now what is the next point there, ma? The next point mentioned there is that D starts after the completion of B. Where B is done, ma? B is done here. From there I will start D. Is it fine? Sir, anyway, is it fine or not? So, sir, the basic fundamental rule is being violated. What is the basic fundamental rule? 2 ending points. This is not at all appropriate. So, just to follow the basic fundamental rule, I am joining the D till C. Is it done? This is a perfect diagram. Now, once the diagram is done, have a cross check whether all the conditions are satisfied or not. So, what is the last condition mentioned, ma'am? D starts after the completion of B. Sir, D is here. It starts after the completion of B. Fine. What about next one? C starts after the completion of A and B. Where is C, sir? C, it is here. So A and B. After that, this is a dummy activity is using the logical flow. Na? So never forget to write that thing as a dummy. Okay. So do not use D. If there is a letter D and if you are using again D and it's gone. So represent dummy 1 or dummy 2. If there are more than one dummy, dummy 1 and dummy 2 will be viable. Okay. So if it is done, next. What about the next condition, ma'am? So preceding B, there should not be. Preceding B, is there anything activity like this? No. And what about A, ma'am? Preceding A also nothing else. The basic fundamental rules. Are the fundamental rules clear, ma'am? If the fundamental rules are clear, if the network diagram is done, the 50% of the work is done, ma'am. Because based on the network diagram only, we are framing everything. Okay, like for example, crashing, or if you are calculating the estimated time t value and all, or if you want to calculate variance, if you want to calculate standard deviation, for these all things, what is the base, ma? Diagram is the base. And if you want to identify the critical path, also the base is the diagram. So be perfect with the construction diagram. Okay, and if it is done, let us go with this diagram first. Sir, basically, I want to be clear with the diagrams. If you are perfect with the diagrams and all, you are safe with the process. So let us have quick practice, ma'am. So here in this case, what is the first activity, ma'am? The first activity is A. Preceding there is nothing. So it is starting one. So starting. Next, what about next information, ma'am? Sir, BC will start. BC will start after the completion of A. Superb. So I will start BC after the completion of A. This is B and this is C. What about next, sir? He has given the other part. What is the other part, ma? D starts after the completion of B. Superb, sir. I will do that part also. After the completion of B, D starts. What about next one, ma? In this diagram, he is telling E will start after the completion of C because this is activity and preceding activity column. So the next part is this. This is E. Clear? Now, what is the next point he mentioned, ma? Sir, he is telling that F will start where D and E will end. So D and E should end now, sir. So I will have a connection like dummy. I'll use the dummy part. I'll use a dummy part and I will complete the connection. Okay. From that I will go with F, sir. From there I will go with the G, sir. Is it fine? What are the basic rules for dummy? I said, sir, basically two activities are having same starting event, same ending event. This is the first case of using dummy. And what is the second case, ma? An activity repeats twice. Okay, in the preceding column, once individually and with other column. Are those two conditions satisfied and none is satisfied? Then what is the need of using dummy? Is a requirement. So do not use dummies as they are not representing any resources and all. Do not use them unnecessarily. Just connect this one. Is it violating any rule, ma? It is not violating any rule. That's a perfect thing. Okay, is the diagram clear? If you're done with the diagram perfectly, once the thing other part is that check it logically. Okay, from the question, sir, F G starts when F completes. Sir, G is here and F is starting. Super. What about D? F will start where D and E ends. D it is here and E it is here. Started. Fine. What about next E and C? Sir, basically, sorry, E starts when C completes. Fine. What about D? D starts when the completion of B. Fine. What about A? So what about B and C? B and C will start where A ends. And what is the A rule? Please clear the discipline thing. Okay, clear? If it's clear, it's fine. Next. So try to do this one. You try to do this once. Pause the video here and try to solve that. If you are done with the time, which will go for the levels. Okay. Shall we do it, ma? Sir, normally in this case, he gave two activities. What are those two activities, ma? First one, A, there is nothing preceding. B also there is nothing preceding. So they are concurrent activities. They are starting simultaneously. So in this case, it is A and it is B. And one more most important point, I'm repeating again, while you're drawing a diagram, consider the pencil in the rough first. Then you can go with that part. Okay. And next. So what is the next part, ma? C starts when the C is starting after the completion of A. And even D starts after the completion of A. So two are starting at the same point. They are burst events. They can also be known as what, ma? Burst events. So for example, C and D. Clear? What about next one? In the next case, E starts where is the completion of C and B. So sir, one more point. E starts when where C and B ends. Sir, should I join like this in short line? It is not appropriate. The line should be in a straight way and there should not be intersecting lines for sure. Okay. So now for our sake and convenience, I am changing these points. It is D and it is C. Am I doing any wrong? No. And for our more better convenience, I'm extending like this. That is the reason why I will ask you to go with pencil first. If you're going with a pencil, then you can rearrange them as per requirement. And so once it is done, you can go with the construction. Now, what is the next one, ma'am? So we are done with this condition. Next, F starts where D and E ends. Where D and E, sorry, E starts where C and B ends. So let us do that part first. This is E. So this is the point. This point is satisfied. Now, what about F? F starts where D and E ends. Sir, can I use a dummy here? They're appropriate, fine, but are the two conditions satisfied? No. When the two conditions are not satisfied, the way you are using the dummy is not appropriate. So simply extend the line. Done, sir. I extended the line, it is done. Clear? Now, sir, what is the point there, ma? F starts when D and E ends. So go with the point. Here it is F. Clear? Now, what is the next last scenario, ma? G starts where completion of F. So F is done. We shall continue that part. That is clear. Why I am concentrating only on the network diagram is that is the base part. If that part is done, you can calculate easily the critical path, you can calculate the float and all, you can calculate standard deviation, you can calculate variance. So that is a basic important part. Is it clear, ma'am? Sir, and once the diagram is done, go with the cross check of the questions. Go with the points. If you're done with the points, then it's fine. Sir, till here we are done with the basic construction of network diagram now. Now the basic part is that in the network diagram, the most important thing is that to calculate the project duration. What is the time taken to complete the project is important. Am I clear? So that is nothing but the time taken to complete the entire project. Sir, see the point there, bro? So time taken to complete the project is nothing but project completion time or a project duration. Because normally each activity consumes some time. For example, for any activity 2 days, 3 days, 4, 1, 2, 7, 9. So there is a time taken to consume that complete that activity. So this we need to calculate the total for the project duration. Sir, as the time is given, just by taking the calculator and adding the total is not appropriate because there are some process. Sir, that won't be effective. You may calculate like 2 plus 3 plus 4 plus 1 plus 2 plus 7 plus 9. This is absolutely wrong. Now we are not required to go through reason and all. Basically, to calculate the project duration, what we should do first? The basic fundamentals. First, construct the network diagram. Superb, sir. We are done with that part. Anyway, I have solved three things so that we get clarity. Next, what? Identify the alternative paths from the starting event and ending event. For this diagram, what is starting event? This is starting event. And this is ending event. From this all, basically, what is the point there? So this is a starting event. Sorry. So this is a starting event, this is an ending event. What are the alternative paths we are having? Sir, what are the alternative paths we are having from starting to the ending? That is important. Sir, this is one path, and this is the other path, and this is the third path. Totally three paths are there. So identify the number of routes from the starting event to the ending event. Okay, that's the basic thing. See that part. Identify the alternative paths from the starting event to ending event. Okay, and after identifying the paths, what you should do, ma? You should do the totaling up. For example, in this diagram, what are the alternative paths from the starting part to the ending part? So basically, that is A, D, I, F, and G. That is one path. Next, A, C, E, F, and G. What is the third case, ma? B, E, F, and G. These are the three alternative paths we are having. So when we are having these three alternative paths, what is the basic thing we have to do, ma? Just add the total of the duration of that path. So for A, how much is the time? I mentioned 2. Okay, so 2 plus 4 plus F7 G9. That is the duration for the entire that path. Sir, alternative paths. That is, three alternative paths are identified now. Once the three alternative paths are identified, calculate the duration for that path. Okay. So for the second path, what is the duration, ma? 2 plus 1 plus 2 plus 7 plus 9. Okay. And for the third path, what is the duration, ma? 3 plus 2 plus 7 plus 9. What is the total for this duration, ma? How much, buddy? 13 plus 9, 22. Am I right? 16%. Okay. Next, what is the second case, ma? In this case, what is the duration? 16 plus 5, 21. What about last one, ma? 16 plus, again, it is also 5, 21. Okay. Once this part is done, what is next, sir? Identify the path with the highest duration. What is that, ma? Identify the path with the highest duration. So of all this, what is the highest duration, ma? ADFG is the highest duration path. So, and that you need to mention with a double line. Double line should be mentioned for that path. That is most important, ma. If you mention that one with a double line and all, that will be the critical path. Sir, we are using the new word there. What is that word, ma? Critical path. That path duration will be the duration of entire project. Okay. Sir, once I'm repeating the process, sir, we identify the alternative paths from the starting event to ending event, and we mention in order. Of that, we can take the highest one. That highest one will be the duration for the entire project, and this is also known as critical path. The activities in the critical path should not be delayed. If delayed, entire project will get delayed. Is it clear, ma? If you're delaying the activities in the critical path, entire project will be getting delayed. Is it clear? So now the same points are mentioned here. So what is that point now? Highest duration is known as project duration. Also minimum time for completion of project. So highest duration, that is in our case 22 days now. This is a minimum time to complete the entire project without any delay, basically. Okay. So when this part is done, what is the next point, ma'am? Minimum duration is equal to maximum time to complete the sequence. For a minimum time to complete entire project is the maximum duration of paths. 33 paths are there. That is about it. Okay. Now, so it is also known as what, critical path, basically, and this is mentioned with a double line. Okay. So one thing is that when you are constructing the diagram with a pen and all, first off pencil, you try it, you check the conditions. If they are satisfied, then go with identifying the paths. Okay, and automatically make it with the pen also perfectly. Then mention it with double lines. Draw the diagram legibly. It will be effective. Minimum neatness is required. So by seeing this question, we shall solve the problem basically. Shall we? Shall we solve this one, ma? So now let us go with the critical path, ma. By seeing this diagram, first basic fundamental thing. So for anything, the basic logic is that we need to consider the diagram. So here in the question A, B, C, in the preceding there is nothing there. So there is nothing preceding them. So they are the starting parts. They are starting simultaneously. Is it clear? So as it is clear, this is A, this is B, and this is C. 3. Now what is next one, ma? D starts after the completion of C, and E starts after the completion of E. Next, what is he mentioning, ma? He is giving information that F will start after the completion of B, E, D. Sir, how to join them? Sir, let us go with the dummies. So I will construct dummies like this, and I will construct dummy like this, and finally I will start. Is it fine? No. Why, sir? Dummy, there are only two rules. Only then we have to use the dummies. In other cases, never use dummies. Am I clear, ma? If I'm clear, so that is the reason why I humbly request you to construct with a pencil. So now for our convenience, we are extending the B2 till here. And I'm rearranging E. And even I'm rearranging D also. Now, sir, where BED ends, who will start, ma? F will start. Clear now? Once the diagram is done, the thing is that you have to go with the cross check whether our diagram is appropriate or not. The F will start where, ma? Where B, E, D ends. Fine, superb. What about next E, ma? E starts where A ends. Superb. What about D starts, ma? D starts of the completion of C. Fine, sir. Superb. A, B, C. Preceding that there is nothing. So A, B, C. There is no preceding. Our diagram is a perfect diagram. Then what is X1, ma? Plot the time on the activities. Sir, for A, what is the time given there? 3. Okay, and for B, what is the time given there, ma? 7. For C, the time given is 4. Is it clear? If it is clear, next thing is what, ma? Now, the next part is what, ma? Sir, for a D, what is the time taken there? 6 days. For E, the time taken is 5. And for F, the time taken is 3. Now, when you are asked to calculate the project duration, what you should do? This is a starting event, this is an ending event. What are the alternative paths? We need to identify it and represent or present them in a proper way. Sir, is the diagram clear? If it is clear, I'm going with the part. So, serial number, paths, and duration. These are the 3 columns we need to maintain. So, for example, the first path, what is the first path, ma? A to E, E to F. That is the first path. What is the second path, sir? This path should be mentioned the path part now. Sorry. Okay. This is the serial number 1. Now, what is the duration for this path basically? Okay. So you can calculate the duration now, or after completion of all the alternative paths, you can calculate. So let's, what is the second path, ma? That is B to F. Next, what about third one, ma? C to D, D to F. These are 3 alternative paths. Now, what is the duration there? So basically, duration how to get, ma? Just add the time given on the activities. That is 3 plus 5 plus 3. And what about next one, ma? 7 plus 3. Next one, 4 plus 6 plus 3. Okay, in these cases, what is the duration total here? How much more it is? 11, 10, and the last case it is how much more? 13. Sir, we have done the calculation of duration for all the alternative paths. And then what is the project duration, ma? Of all these, what is the highest, sir? 13 is the highest. That 13 path is the project duration total. And this path is known as what, ma? Critical path. Okay. So now in this case, what is a critical path, ma? CDF. So it should be mentioned with a double line. I mentioned with a double line. Sorry. Okay. As a critical path is mentioned with a double line, there you write the project duration. Sir, whatever summary is important, ma. If you're not writing summary and all, they'll cut the marks. So summary is that project duration is equal to how much more? It is 13. That is highest of all the paths. And critical path, they may ask in exam critical path also. The critical path is, what is it, ma? CDF. So if you're writing that, then you will get full marks. Am I clear? So this is a way of construction of critical path and all basically. Okay. Now if it is fine, next most important thing is that float calculation. Okay. So float calculation basically, go the exact definition, ma. Float is the amount of time the activity can be delayed without impacting the overall project completion time. So there can be chances for us to delay some activities without delaying the project duration. Okay, that's the point. Next, the very basic step in the class of float. I'm not going with the basic concept and all. So what is float and all? If you're having brief idea, that is sufficient. So without delaying the project, we are delaying an activity. That's the point. Okay, sir. So for the sake of float calculation, I'm going with this base. The base is that first we need to construct the diagram, and then we have to calculate E and L values for each event. What is it, ma? For each event, we have to calculate E and L values. Okay, so for E and L values, there are fundamental rules. Okay, based on that rules, we can go with the point. If it is a regular class, I used to explain everything, but it is exam-oriented point of view. I am going with only the process, so that while revision and all, it will be effective for you. Okay, so float. If you are having this brief idea, that is sufficient. And the very basic step, what is that my E and L values for each event. So here, once the diagram is done, this node or event, for that we need to calculate E and L values. Am I clear? If I am clear, shall we? So these are the rules for E value calculation. What are the rules for E value calculation, sir? E value of a starting event will always be 0. So here, what is the starting event? 1 is the starting event. For that, the E value will be, what is that buddy? 0. Clear? Next, what is next point? E value goes from left to right. What is left to right, ma? From this to like this, or like this, left to right. Never from right to left. Left to right. Next, what is the next point there, sir? E value will be always highest if they are having more than one events. Sir, to reach a point, to this point, we are having two paths. So if you calculate the E value, take the highest one. I will explain, but the basic fundamental principles I'm telling. Okay. Next, we need to calculate E value for critical path first. Basic rule. Okay. So if I are calculating the E value for a critical path, it is more effective basically. Okay. Once the E value is done for the critical path, then the basic logic or basic simple theme is that L value for the critical path activities or events also will be same. E and L value in the critical path will be same. Okay. And basically remind one thing, E stands for earliest start time. Earliest start time. Okay. So E stands for what, ma? Only earliest start time. That is the basic thing. So now let us follow the basic rules and try to calculate the time. How to that? Okay. Sir, what is the basic first rule, ma? E value of starting event is 0. Sir, superb. I mentioned 0. Okay, fine, sir. But before that, we have to enter the critical path. No? What are the alternative paths, and we have to identify the critical path. So see the point that's first. What are the alternative paths? So for example, 1, sir, they can be representing an activity with the letters or numbers. You know that. Based on that, we are doing it. Shall we? Yes, sir. So diagram is done. Before going with E and L value, what is the basic thing, ma? We need to identify the critical path. For identifying critical path, what is most important, ma? Most important thing is that we need to go with the paths. So serial number, paths, and duration. Okay. Sir, the activities can be represented with the letters or numericals. Numericals will be both combinations. So from that, we can identify the serial number. First, what is the path, ma? 1 to 3, 3 to 4, 4 to 6, 6 to 7. That is one path. This is the path. Is it done? So because starting event, ending event. Next, what is second path there, sir? Second path. What is done? Next, 1 to 2, 2 to 4, 4 to 6, 6 to 7. The second path. 1, 2. What about next one, ma? Third one, third alternative. Third alternative is nothing but 1 to 2, 2 to 5, 5 to 6, 6 to 7. So this is the alternative path. The first path done. Is it the first path done? 1 to 3, 3 to 4, 4 to 6, 6 to 7. Next, what about second path, ma? 1 to 2, 2 to 4, 4 to 6, 6 to 7. Next, what about next one? 1 to 2, 2 to 5, 5 to 6, 6 to 7. Now calculate the duration, ma. For the first path, what is the duration, sir? 4 plus 6 plus 8 plus 3. For second path, what is the duration, ma? 6 plus 5 plus 8 plus 3. And for the third path, what is it, ma? 6 plus 3 plus 4 plus 3. Is it clear? The most important thing is that while you are drafting the values and all, be careful. If you are drafting something wrong, go on there, it's gone. So be careful with these areas. Okay. So now what we should do, sir, just calculate, take the calculator, because my humble request, do not use your mind. Use a calculator, my humble request. So it is good for you. The point is that what, ma? Here it is 21. Right? Next, what is that next one, ma? 22. Clear? And in the last one, what is the value, ma? It is 16. So of these three, which is the highest, ma? 22 is the highest. So 22 is this path. Okay, that is a project duration, and this is what, ma? Critical path. Okay, the critical path should be highlighted by using double lines. Is it clear? So now as it is done, now it is easy for us to calculate E and A value on this. So what is the basic rule I mentioned, ma? For the starting event, basically E value will be 0. In the critical path, what is the next event? That is 2. So just add the duration. 0 plus 6. What is that, ma? 6 is the duration. Next. Sir, what is the next event in the critical path? 4 is the next critical event. For that, how to calculate, sir? Sir, here to reach this point, how many alternatives are there? This is one alternative and this one alternative. Of these two alternatives, which gives the highest value, that should be taken as E value. Okay. So if I go with this point, E value will be 4 plus 6, 10. Okay, that is one option. The one option is I'm having is 10 for this point. Okay. And what is the other option, ma? The other option is like this. Here already calculated E. That is 6 plus 5. So whatever project duration it is there, we are adding to that previous one. That is, what is the option there, ma? 11. Which is the highest? 10 or 11? 11 is the highest. So mention the value 11. So the value will be 11 here. Is it done? If that part is done, next event in the critical path is this. So for this, what are the alternative paths? The one path is like this, as you are in like this point. What is the value there, ma? Basically 11 plus, what is the duration here? 8. 11 plus 8, that is 19. Then if you go with this next alternative path, what is the next alternative path, ma? Like this. You already E value is done, that is 6. 6 plus 3, that is 9. 9 plus 4, how much, ma? 9 plus 4, 13. So two options, 19 or 13. Which is highest, ma? 19. 19 is the highest. So mention the 19. Okay. And the last one is what, ma? Just for this point, are there any alternative paths? No, one path. That is 22. And one more basic point and basic logic. Sir, here the highest path value is 22 na? And the value also will be same, 22. Okay, because we are adding the same path na? So when you are in exam and all, these things may help you the best. So be careful with this area. Sir, again I'm repeating how to calculate E value. So for starting event it's 0. For that we are adding the duration. Then we are getting the 6 value. And that too we are completing the critical path. And for critical path, if it is done, next what, ma? Again 5. That is 6 plus 5, 11. For here, this point there are two paths, one path and two path. Wherever we are getting highest value for E, that is opted, that value is taken. Next 11 plus 8, 18. This is one way and this is also one way. 19 or 13, whichever is highest, 19. So at this point we are adding 19 plus 3. So whatever duration mentioned, that we are adding to that. Okay, is it clear, ma? If it is clear, the value is same. And without wasting any time, you can go with a simple logic, sir. In a critical path, E and L values will be same. So if you go with that option, it will be good for you because exams. That is 22, 19, and 6. Done with these paths. And even the critical path, it is there, no? This level. You can have a cross check. Okay, sir, for L value, what are the basic fundamental rules function here, ma? L value of a starting event is 0. For sure, 0, sir. I'll mention 0, so no issues, sir. And L value starts from where, ma? It goes from right to left, quite opposite to E value. E value starts from what, ma? Left to right. Okay, and L value starts from right to left, reverse. The reverse direction. So basically at the end, that will be the project duration. Okay, and next. E value will always be the lowest if more than one alternative path it is there. E value we need to calculate E value for critical path first. That's the basic rule. And one more thing, ma, at the end event, whatever we are having the E value, that will be same for L value also. That is fine. Okay. So an L stands for, what is the meaning of L? Latest finish time. What is that, ma? Latest finish time. E stands for earliest start time. E stands for EST, 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 EST. Okay, exam oriented mainly. Okay, na? Sir, L stands for LFT, 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 LFT. Clear? And E starts from right to left or left to right? Left to right, E. What about L, ma? Quite opposite. Right to left. Okay, so that is most important thing. Once the critical path E and L values are done, we have to go with our values. So here, let us complete E values first. The E, so what is left over, ma? Two things are left over. For that, how to calculate E values, sir? Basically, at this point, 0 plus duration. What is that value, ma? It is 4. So 4. For this point, are there more than one alternative path? No. Done. What about next this one? To reach this point, how many alternative paths are there? Only one path. There is this path. So automatically, what is the value? 6 plus 3. That is 9. Okay, what about L values? L value starts from right to left. Okay, so that is in reverse direction. Okay, so when you are in reverse direction, to reach this point, any alternative path from here to left? Only one alternative path, one path. That is 11. Sir, when we are calculating E value, we added the duration. But when we are calculating L value, did the duration. That's all. So 11 minus 6. Okay, how much is the value? 11 minus 6. That will be 5. Okay, and here to reach this point, are there any more than one alternative path? No, only one path. And there is one path. The thing is that 19 minus 4. 19 minus 4 is what is the value of 15. So for E value we are adding, for L value we are deducting. And E value starting event 0 and for L value also same, starting event 0. And we have to calculate E and values for critical path first, basically. And one more logic, E stands for left to right, left to right, left to right. And L value right to left, quite opposite. For E value we are keep on adding and L value we keep on deducting. That's the basic point. Is it clear, Bob? If this part is clear, then Bob. Next, what is next part, sir? Now we done with the A and L values. Basically, what is the next three formulas now? Three important formulas. What are those three important formulas, sir? Total float, free float, and independent float. First, you need to calculate total float. What is the value, sir? Total float. Either LST minus EST or LFT minus EFT. What is this, sir? That we should understand. Sir, basically, when you are calculating E and L value, E stands for what? EST. L stands for LFT. That you remember. Basically. Okay. And what is the formula, ma? LST minus EST. Okay. And what about free float, ma? Total float minus head slack. Difference between E and L values of the head event. That is the reason why I said head event and tail event are most important. And what about independent float, ma? Whatever free float we got, from that we are deducting tail slack. Okay. Is this clear? If it is clear, I shall solve a problem for this also. But let us go to the basic fundamentals. For activity, this activity, it has a tail part, it has a head part. For a tail part, we'll definitely calculate E and L values. For a head part also, we'll calculate. Normally, when they are asking us to take EST, that is tail parts part. Tail parts, E value. When they are asking us to calculate E value, head part, L value. That is the most important logic. And what are the next formulas for D? EST stands for E value of a tail part. EFT is nothing but EST plus duration. L stands for LFT. Remember those points. L value of the head part. Next, LST LFT minus duration. Quite opposite to these things we are doing this. Is that clear? If it is clear, okay. Now, based on this, we will upload some other problems also so that you can solve. And two most important, that is time calculation is also most important. The time calculation we are having 4 times normally. Expected time, optimistic time, most likely time, pessimistic time. And we need to calculate this one. They will be giving these 3 values basically. And using this itself, we are calculating T, the formula, and also we are having the variance calculation. That we shall go with the problem. Okay, shall we?